Okay, in this video, I want to give you a few more examples of solving linear equations using substitution, and then we'll look at elimination. So first of all, let's talk about substitution. When we have a linear system of equations, we have more than one equation. We want to look at this equation and solve for one of the solve one of the equation for one of its variables. I should do that, huh? When possible, solve for a variable that has a coefficient of 1 or negative 1. Well, there's an obvious answer here. I should solve this for y because it has a coefficient of 1 or negative 1. So this becomes, if I subtract 2x from both sides, right? Y equals negative 2x plus 9. All right, step 2 says, substitute the expression from step 1 into the other equation and solve for the remaining variable. So in the other equation, wherever there's y, I can substitute negative 2x plus 9 because they're equal to each other. So this becomes 4x minus y. Now y is this quantity. Put it in parentheses. Equals negative 15. I need to put it in parentheses because in this equation I have to distribute this negative sign. So when I do that, I get 4x minus a negative 2x minus 9 equals negative 15. So I'm going to simplify this side by collecting like terms. 6x minus 9 equals negative 15. Now I'll solve for x. Plus 9, right? 6x equals negative 15. Plus 9 is negative 6. X equals negative 1. Step 3 says, substitute the value from step 2, which is this, into the revised equation from step 1 and solve. So now I know that y equals negative 2 times x, which is negative 1 plus 9. Negative 2 times negative 1 is 2 plus 9 equals 11. So it looks like it's negative 1, 11. So I'm going to eyeball this and say negative 2 plus 11, yep. Negative 4 minus 11. So that works because I just plugged them in here and saw that they work. Let's do the second equation, the second system of equations. So it makes sense to solve for this y. It's the only thing that has a coefficient of 1 or negative 1. So first I'm going to subtract 9x from both sides, right? So I get negative y equals negative 9x plus 33. Now I'm going to divide the whole thing through by negative 1, which just changes my signs, doesn't it? So now I have y from step 1. We will substitute it into the other equation. 5x plus 4 times 9x minus 33 equals 32. All right, 5x, this is plus 36x minus 132 equals 32. Combine like terms. 41x equals, I'm going to add 132 to this, 146. If I take 146, right, and divide by 41, I hope that comes out to what I want it to come out to. All right, I made a little mistake here. 132 plus 32 is 164. If I divide by 41, I end up with x equals 4. So then I substitute the value from step 2 into the revised equation above. My revised equation right here, I'm going to come over here, y, let's get rid of this thing. I'm going to come up here. Y equals 9 times x, which is 4, minus 33. 36 minus 33 equals 3. I have an x of 4, a y of 3. So let's see if that works. 5 times 4 is 20, plus 4 times 3 is 12 equals 32, yep. 9 times 6 is 36, minus 3 is 33. It works. So those are two examples using substitution. Let's look at elimination. So in elimination, we're going to use addition. We need to make sure we have one variable that has the same coefficient but different signs. So let's look at this. Well, first of all, they need to be set up in the right format, in the same format. So let's take this and say now I have 3x plus 4y. This is the first equation. The second equation I'm going to subtract 3x over on both sides. So I probably should do that a little more neatly, huh? Negative 3x, negative 3x. So this equation becomes negative 3x plus 2y equals 6. All right? So right up here, negative 3x plus 2y equals 6. So I do have the x's here with different signs, but the same coefficient but different signs, right? So I'm going to add these two equations together. 3 plus a negative 3, that's 0. 4 plus 2 is 6y. Negative 6 plus 6 is 0. Well, guess what? Y equals 0. The third step says substitute the result from step 2 into either equation to find the value of the eliminated. So I'm going to take this equation. 3x plus 4y, which is 0, equals negative 6. 3x plus 0 equals negative 6. I'm going to divide by 3. X equals negative 2. So my answer looks like negative 2, 0. So if I check that, it works. All right, let's try this other one. Now these are in the same form, but I have 7x and 7x. I need one of these to be negative. So I'm going to multiply that equation through by negative 1. So I'm rewriting the first equation. I'm multiplying through the second equation. Negative 7x plus 3y equals negative 4. All right, let's add these equations together. 7x minus 7x, 0. Negative 2 plus 3 is y. 5 plus a negative 4 is 1. Well, I got y equals 1. Now I can plug that into either of these original equations. So I'll take 7x minus 2 times 1 equals 5. 7x minus 2 equals 5. I'll add 2. 7x equals 7. X equals 1. Let's see if that works. 7 minus 2 equals 5. Yep. And 7 minus 2 equals 4. That works. And my answer is 1, 1. So go through these examples as practice for the quiz. If you have any questions, please let me know. All right. Thanks.